Good day, everyone. Today, I will be discussing to you about coterminal angles. But the question is, what do we mean by coterminal angles? Coterminal angles are angles in standard position, angles with the initial side on the positive x-axis that have a common terminal side. Let's have an illustration. This is an illustration of coterminal angles. As you can see, 120 degrees and negative 240 degrees are coterminal to each other. Why? Because they have the same terminal side. Let's have another example. For instance, we have 60 degrees and 420 degrees. The first thing that we're going to do, we're going to draw a Cartesian plane. After drawing a Cartesian plane, we're going to draw angle representing 60 degrees. And this is the angle representing 60 degrees. Now, the next step is to draw angle representing 420 degrees. And this is the angle representing 420 degrees. Why? Because one revolution is equal to 360 degrees. Therefore, we're going to add another 60 degrees. Therefore, the angle that represents 420 degrees is this one. As you can see, 60 degrees and 420 degrees have the same terminal side. Thus, it implies that 60 degrees and 420 degrees are coterminal to each other. Let us answer this one. Identify two angles coterminal with 35 degrees. The first thing that we're going to do, we're going to apply the formula. The formula that we can use is theta plus 360k, where k is an element of integers. So in order for us to know the two angles coterminal with 35 degrees, we can set any two integers for this formula. So let's set k is equal to 1 and k equals to 2. Let us now use the formula theta plus 360k. Your theta is equal to 35 degrees. So let us now have the substitution property. So instead of writing theta, we're going to write 35 degrees plus 360 times 1. Since we set k is equal to 1, we can now have 35 plus 360 times 1. The answer is 395 degrees. For k equals 2, we can have theta plus 360k. Let's write first the formula. And then let's substitute 35 plus 360 times 2. And 35 plus 360 times 2 is equal to 755 degrees. Therefore, we can say that the two angles coterminal with 35 degrees are 395 degrees and 755 degrees. But the question is, are there any angles that are coterminal with 35 degrees? Yes, because it depends on the integers that you're going to set with the formula. For instance, you're going to set k equals negative 1, k equals negative 2, or k equals 10. It's up to you. But just always remember, you're going to get different answer from this presentation. Let's try another example. Identify three angles coterminal with negative 320 degrees. So, we're going to use k equals 1, k equals 2, and k equals 3. Let us now apply the formula theta plus 360k and then substitute the given values. Our theta is equal to negative 320 degrees. So let's have negative 320 plus 360 times 1, and the answer is equal to 40 degrees. For k equals 2, we're going to have theta plus 360k. So we're going to have negative 320 plus 360 times 2. The answer is equal to 400 degrees. For k equals 3, we're going to have theta plus 360k. Let us now substitute. We have negative 320 plus 360 times 3. And the answer is equal to 760 degrees. Therefore, The three angles that co-terminal with negative 320 degrees are 40 degrees, 400 degrees, and 760 degrees. If and only if you substitute the values k equals 1, k equals 2, and k equals 3. Let's try another example. Identify two angles coterminal with pi over 3 rad. So as you can see, this is different. Our first example and second examples are representation of degree measure. However, our next example is a representation of radian measure. So the first thing that we're going to do again, we're going to substitute k equals 1 and k equals 2. We have formula theta plus 360k. However, just always remember 360 is equal to 2 pi. Just always remember why it's 360, because in just one revolution we have 360. The same thing with 2 pi. So instead of writing 360, we're going to write 2 pi. So let's substitute. Our theta is pi over 3 plus 2 pi times your k, which is equal to 1. Pi over 3 plus 2 pi is equal to 11 pi over 3. Right. Now for k equals 2, we're going to have theta plus 360k. So we're going to substitute pi over 3 plus 2 pi. Instead of writing 360, we're going to write 2 pi because our given measure is in radian measure. And then, instead of writing k, we're going to write 2. So we're going to have pi over 3 plus 4 pi. And the answer is 17 pi over 3 rad. Therefore, the two angles coterminal with pi over 3 rad are 11 pi over 3 rad and 17 pi over 3 rad. Okay. Now, how about if this is the given problem? Find the angles of least positive and largest negative measure coterminal to 450 degrees. First thing that we're going to do, we're going to check about the sign of the given angle measure. The sign of the given angle measure is positive. Therefore, we're going to use the formula for positive in finding least positive measure and the formula for positive in finding the largest negative measure. So, let's write first the least positive measure. And then let's write the formula theta minus 360k. In order for us to know the value of k in this example, we're going to divide the angle measure by 360. Let's divide 450 by 360 and the answer is equal to 1.25. Thus, we will just simply get the whole number and the whole number is equal to 1. We can now say that k is equal to 1. So now, we're going to substitute. Instead of writing theta, we're going to write 450 minus 360 times your k, which is equal to 1. Now, 450 minus 360 times 1, the answer is 90 degrees. Therefore, the least positive measure coterminal to 450 degrees is equal to 90 degrees. Now, how are we going to find the largest negative? To find the largest negative, we will just simply use the formula theta minus 360 quantity k plus 1, where k is an element of integer. We already have the value of k, which is equal to 1. So let us substitute 450 minus 360 times 1 plus 1. And the answer is equal to negative 270 degrees. So the largest negative coterminal to 450 degrees is negative 270 degrees. Other way around, if you already have your least positive measure, 90 degrees, to find the largest negative without using the formula, you will just simply subtract this by 360. So 360, so 90 minus 360, the answer is equal to negative 270 degrees. So we can get the same answer, even we will not use the formula. Let's try another example. Find the angles of least positive and largest negative measure coterminal to negative 1935 degrees. First, we're going to check the sign of the degree measure, and the sign of our degree measure is negative. Therefore, we will be using the formula for negative in least positive measure and negative for largest negative measure. So let's write least positive and then apply the formula 360 quantity k plus 1 plus theta. So now we're going to find the value of k. So to find the value of k, we're going to divide our degree measure 1935 divided by 360. And the answer is 5.375. So the whole number is 5, therefore k is equal to 5. Let us now substitute. So we have 360. Instead of writing k, we're going to write 5 plus 1 plus our theta, which is negative 1935. So we're going to have 360 times 6 minus 1935. And the answer is 225 degrees. So the least positive measure coterminal to negative 1935 degrees is 225 degrees. For largest negative, let's apply the formula and the technique. For largest negative, we have theta plus 360k. Let us substitute negative 1935 plus 360 times k, which is equal to 5. We're going to simplify this one. The answer is negative 135 degrees. Using the technique, we will just simply subtract the value that we get on least positive, which is 225, minus 360, and the answer is also negative 135 degrees. So as you can see, we can get the same answer. Let's find the least positive and largest negative angle coterminal with 137 pi over 5. As you can see, the given angle measure is in radian measure. So the first thing that we're going to do, we're going to check the sign of our angle measure, and that is positive. So we're going to use this formula for least positive and this formula for largest negative. So let's now write the least positive. And then let's write the formula theta minus 360k. Now to find the value of k, we'll just simply divide the angle measure by 2. So we're going to have 137 over 5 divided by 2. So it will be equal to 137 over 5 times 1 half. We will just simply write the numerator, which is 137 over 5, and then get the reciprocal of the value of the denominator, which is 2, and it will become 1 half. Then multiply, it will be 137 over 10. Now it will be 13.7. So therefore, getting the whole number, k is equal to 13. So we already have the value of k, which is equal to 13. So we can now substitute the given value. So instead of writing theta, we're going to write 137 pi over 5 minus, instead of writing 360, we're going to write 2 pi. Why? Because the given angle measure is in radian measure. So we're going to write 2 pi times your k, which is equal to 13. So 137 pi over 5 minus 26 pi, and that's equal to 7 pi over 5. So therefore, the least positive measure coterminal with 137 pi over 5 is 7 pi over 5. For largest negative, we will just simply use the formula. Let's write the formula theta minus 360 quantity k plus 1. Let us now substitute 137 pi over 5 minus, instead of writing 360, we will be writing 2 pi. Instead of writing k, we're going to write 13 plus 1, and that's equal to 137 pi over 5 minus 2 pi times 14. And that's equal to negative 3 pi over 5. So the largest negative coterminal with 137 pi over 5 is negative 3 pi over 5. We can also use the technique. So in our technique, for largest negative, we will subtract the least positive by 2. So it will be 7 pi over 5 minus 2 pi. If we're going to subtract 7 pi over 5 minus 2 pi, we can get also negative 3 pi over 5. So it's up to you if you're going to use the formula or you're going to use the technique. Let's try another example. Find the least positive and largest negative angle coterminal with negative 107 pi over 6. So again, we're going to check the sign of the angle measure, and the sign is negative. So we will just simply use this formula for least positive and this formula for largest negative. So now let's write the formula. For least positive, let's write the formula 360 quantity k plus 1 plus theta. Now to find the value of k, we will just simply divide 107 over 6 divided by 2. It will be 107 over 6 times 1 half. And that's equal to 107 times over 12. Which is equal to, if we're going to transform this improper to mix, it will be equal to 8 and 11 over 12. So you can see the whole number is 8. Therefore, k is equal to 8. Let us now substitute. Instead of writing 360 again, since the given angle measure is in radian measure, we can use 2 pi. Times, instead of writing k, we're going to write 8 plus 1 plus your theta, which is negative 107 pi over 6. So it will be 2 pi times 9 minus 107 pi over 6. Simplifying this, we can get pi over 6. So therefore, the least positive angle coterminal with negative 107 pi over 6 is pi over 6. For largest negative, let us only use the technique. The technique is just simply subtract the least positive pi over 6 minus 2 pi. And the answer is negative 11 pi over 6. And that is the largest negative angle coterminal with negative 107 pi over 6. Let us now proceed with determining if the two angles are coterminal to each other. In order for us to know if the two angles are coterminal to each other, we will just simply subtract the two angles, and the difference should always be divisible by 360 rather. So let's subtract. 370 minus 10 is equal to 360. As you can see, 360 is divisible by 360. Therefore, 10 and 370 degrees are coterminal to each other. Let's try another example. Negative 520 and 200 degrees. Let's subtract. Negative 520 minus 200. The answer is negative 720. Negative 720 is divisible by 360. Therefore, negative 520 and 200 degrees are coterminal to each other. Let's try this one. Negative 10 pi over 3 minus pi over 3. And the answer is negative 11 pi over 3. Negative 11 pi over 3 is not divisible by 2. If we're talking about radian, it should be divisible by 2. If we're talking about degree measure, it should be divisible by 360. Since this is in radian measure, we're going to check if the difference is divisible by 2. But as you can see, negative 11 pi over 3 is not divisible by 2. Therefore, negative 10 pi over 3 and pi over 3 is not coterminal to each other. So that's all for today's discussion. I hope you've learned a lot for today's discussion. Thank you very much and happy math learning.